Hello family. Had you ever celebrated your birthday? Well, even if you don't want to celebrate also, you have a friend circle who always ensure that you celebrate and go bankrupt on this day. It is everyone's dream to live in a big house which is structurally safe and sound. All these dreams are dreamed and come true in this beautiful planet Earth. But have you ever wondered about our planet Earth, which is the third planet from Sun in solar system? Planet with color and wonder, which is unique in so many ways, offering the perfect conditions for life to thrive. Welcome to our channel Geo Discovery, your go-to channel for all things of Earth. Stay tuned, and don't forget to give it a thumbs up, hit that subscribe button and share it with your friends, so that you never miss out on any new videos. So let's get in. Well, the story begins over 4.6 billion years ago, which is 460 crores years. Our solar system was dark, consisting of vast cloud of gas and dust in space. This cloud, termed as solar nebula, was majorly made up of hydrogen, helium, and other heavier elements created in earlier generations of stars that had long ago exploded in a supernova. These gases and dust kept swirling over millions of years, until when there was a massive explosion that took place nearby nebula, releasing enormous amount of energy in the form of shock waves and radiation. Was this explosion due to Diwali's celebration in space? No, it's not. And this explosion or phenomena has been termed as supernova. Let us see what is supernova. A supernova is the sudden explosion of a star at the end of its life cycle, releasing immense amounts of energy and matter into space in the form of shock waves and heat, which can outshine an entire galaxy for a short time. Now the question is, what do you mean by end of life of a star? Do the stars live like us? Well, the answer is, a star is powered, formed by nuclear fusion reaction for millions of years. The core of the star is continuously undergoing nuclear fusion, where hydrogen atoms fuse into helium, creating heavier elements and releasing immense energy in the form of gamma rays. This reaction creates outward pressure at the core, which is countered by inward pull of gravity. So there is balance between two forces. When the massive star runs out of nuclear fuel, that is hydrogen, it reaches end of its life, and it can no longer produce the energy needed to counterbalance gravity. So there is no equilibrium. Due to gravity, the core collapses under its own weight, and this collapse leads to an extremely energetic explosion, throwing the outer layers of the star into space. Again, there are two types of supernova, type 1 and type 2. So far I explained type 2 supernova, which resulted in formation of solar system, and type 1 is not so important. Shock waves from supernova compressed parts of the surrounding molecular cloud of gas and dust of nebula. This compression triggered the gravitational collapse of the cloud. As the cloud contracted, particles were drawn towards the center in the form of a swirling disk. During swirling, particles started colliding with one another. These collisions, driven by the force of gravity, caused them to stick together, forming larger and larger clumps. This process is known as accretion. Due to accretion, center of this swirling mass became more dense and began to heat up. The temperature and pressure rose drastically, and this was the beginning of what would eventually become our Sun. At this stage, it is termed as protostar, which is not fully fledged one. Well, the major portion of the particles in nebula were taken away by the Sun, which is around 99.8% mass of solar system. Remaining 0.14% mass contributed in the formation of all remaining planets, stars, moon, and other bodies in solar system. Around the newly formed Sun, the material in the outer regions of the disk continued to orbit. Here comes the most awaited part. That is formation of our planet Earth, a journey through time. As I explained earlier, due to accretion process, tiny clumps or particles collided and merged by growing larger and larger, which eventually formed planetesimals, revolving around the Sun. These planetesimals, ranging in size from a kilometer to hundreds of kilometers across, were in molten condition because of enormous amount of energy release in accretion process. During this period, violent collisions with other planetesimals were common. Some of these collisions were so intense that they caused partial melting of the planetesimal surface. One of the planetesimal grew larger and larger over time, which would become a planet. At this stage it is called as early Earth or proto-Earth. So now question is, how did molten Earth turn into a living planet? Well, the proto-Earth, once after growing or reaching the size, the bombardment or collision with other particles was not so aggressive as before, which resulted in minimum heat generation or dissipation. So now the Earth slowly started to cool, but that didn't mean entire Earth was cooled down. Only the outer layer, that is crust, was cooled and solidified, while the inner layers like mantle and core were still in semi-solid and molten state, which are still in same state. As it began to cool down, denser materials like iron and nickel sank towards the center because of high density, while lighter materials like silicates floated towards the surface. This process led to the formation of Earth's layered structure and is known as differentiation. Let us see the different layers of Earth. While the Earth has 5 different layers: core at the center, which is split into inner core and outer core; mantle in the middle, which is split into upper mantle and lower mantle; crust at the surface. Let us see one by one. The outermost layer of Earth is called the crust, and it's the layer we live on. There are 2 types of crust: continental crust and oceanic crust. Continental crust is the thicker crust found beneath the continents. It's made mostly of lighter rocks, like granite, and is about 30 to 70 kilometers thick. Oceanic crust is thinner and denser, found beneath the oceans. It's mostly composed of basalt, and is about 7 to 10 kilometers thick. The Earth's crust is made up of 93 elements. The most abundant elements are oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. Temperature of crust varies from 0 to 700 degrees Celsius. Next, we have the mantle, also known as the layer of movement, the thickest layer of Earth, which lies above the core and beneath the crust. The mantle is divided into 2 parts, upper and lower mantle. The upper mantle is solid, but behaves like a very slow-moving plastic. It's about 670 kilometers thick. The lower mantle is located deeper. This layer is denser, which is around 2,250 kilometers thick. Mantle is the largest layer of the Earth, making up 84% of its volume. The mantle is composed of oxygen, silicon and magnesium, which are the most abundant elements, making up approximately 45%, 21%, and 23% respectively. Temperature of mantle varies from 870 to 4,400 degrees Celsius. The innermost layer of Earth is called the core, and it is primarily made of iron and nickel. It's divided into 2 parts, inner core and outer core. The inner core is solid, composed mainly of iron and nickel, and is incredibly hot, reaching temperatures of about 5,400 degrees Celsius. It extends about 1,300 kilometers in radius. The outer core is surrounding the inner core. The outer core is liquid and made of iron and other metals. It is about 2,300 kilometers thick and temperature reaches up to 5,000 degrees Celsius. It is responsible for generating Earth's magnetic field. So that is about different layers of Earth. And here comes the curious thing. That is appearance of water on the Earth, which was in molten condition earlier. As explained earlier, only the outer layer, that is crust, was cooled down, whereas other layers like mantle and core were in solid, a molten state, which were trying to eject out of Earth's surface due to high pressure. Sometimes these molten rock, gases, and ash were able to eject outside Earth's surface, rupturing or opening the outer layer, that is crust. and this phenomenon has been called as volcano. Let us see the definition of volcano. A volcano is a rupture or opening in the Earth's surface where molten rock, ash, and gases below the Earth's surface come out into the atmosphere. And the word volcano comes from the name Vulcan, who was the Roman god of fire. The eruptions can be explosive or gentle, but no matter how they erupt, they all originate from the same place, deep within the Earth. This molten rock is known as magma when it's beneath the surface, and once it erupts and reaches the Earth's surface, it becomes lava, due to eruption of volcanoes. The gases like water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide were released into the atmosphere. Over millions of years, the water vapor began to condense, forming clouds and eventually filling the lowlands with liquid water, creating Earth's first oceans. So that's how water appeared on Earth. And today, about 71% of the Earth's surface is covered by water. Now we know what is there inside Earth and on the Earth. But how about above the Earth? That is atmosphere, which makes Earth suitable for life. Here also same reason. Due to volcanic activity, Earth's atmosphere was thick with carbon dioxide and nitrogen. The early atmosphere was inhospitable to life as it lacked oxygen. Over time, however, the planet's environment began to change as the time passed. The formation of oceans acted as a major carbon sink, absorbing a significant portion of atmospheric carbon dioxide. This absorption helps to regulate the amount of carbon dioxide in the atmosphere, which is a major greenhouse gas, and thus helps to stabilize the Earth's temperature. One of the most important events in Earth's environmental history was the appearance of photosynthetic organisms. Organisms that use sunlight to make their own food and release oxygen as a byproduct. This process, known as photosynthesis, gradually began to fill the atmosphere with oxygen. The rise of photosynthetic organisms caused a major increase in the levels of oxygen in the atmosphere, known as the Great Oxygenation Event. The Great Oxygenation Event refers to a geological event during which there was a sharp increase in oxygen levels due to emergence of photosynthetic life forms, like cyanobacteria, that led to a major shift in the Earth's environment. As oxygen levels in the atmosphere increased, some of it began to form into ozone in the upper atmosphere. The ozone layer acted as a protective shield, blocking harmful ultraviolet radiation from the sun. So that's how the Earth's atmosphere was formed. And so, after billions of years of violent beginnings, finally Earth became the home of life, as we know it. So now everything was formed and someone was following our Earth. Not on Instagram, but in real life. And he's the moon to whom all girls on Earth are compared. Let's see, how did moon come into existence? Well, again, we will have to move back to 4.5 billion years, when the sun had just formed and other planets were still forming. And the young Earth was a hot and molten sphere. Something extraordinary happened where a Mars-sized object, often referred to as Theia, collided with the early Earth in a catastrophic impact which occurred at a glancing angle, released an immense amount of energy, vaporizing large portions of both Theia and Earth's outer layers into Earth's orbit. These shattered fragments, consisting mostly of silicate rock, began to clump together due to gravity. Over thousands of years, due to accretion, the debris ring surrounding Earth began to coalesce into larger and larger bodies, ultimately forming a single, massive object, and this object eventually became the Moon. Even though the collision between Earth and Theia was violent, it had major advantage on Earth's tilt, the angle at which Earth rotates. As Earth orbits the Sun, different parts of the planet receive varying amounts of sunlight at different times of the year, causing the cyclical changes in temperature and climate we know as seasons. Without the Moon, Earth's tilt might have been unstable, wobbling erratically over long periods. This wobble could have led to dramatic shifts in climate. making Earth inhospitable to life as we know it. Let us see how Earth is benefited by formation of Moon. The formation and gravitational pull of the Moon helped to stabilize Earth's axial tilt at a steady 23.5 degrees, locking it into a more predictable pattern, which otherwise could have tilted much more dramatically, triggering extreme and unpredictable climate shifts. Apart from this, Moon has impact on tides, which is rise and fall of sea level, and also reflection light during night time. And this was how the Moon came into existence and protecting the Earth. So we got to thank Moon every day. So that was about the formation of Earth in the solar system. I hope this video has given you some valuable insights into the formation of planet Earth. Did you find the information useful? I'd love to hear your thoughts in the comments section. So now we know how the planet Earth was formed, and next we will see amazing facts inside the Earth. You can let me know which video are you expecting next, so that I can align with you. Guys, thank you so much for staying till here. Please give it a like and hit that subscribe button and share with your friends too. So that is the end of this video. Take care till we meet in next video. See you soon.